All right, so I would like to go through angle of elevation and depression with you with these problems here. This is in your notes packet, kind of toward the back. I also have it linked on Schoology. So if you don't have this in front of you, you might pause the video until you get a copy of this. I am going to just go through a handful of problems. And the key, I believe, on all of these is to draw the picture correctly. So I actually want to just kind of review over here to the side real quick angle of elevation and depression. So angle of elevation, so like if we have this tall tree right here, and then, here's a person right here, the angle of elevation is going to be, so first of all, there has to be a horizontal distance they're looking at. So if this person is looking straight across at the tree like this, and then they elevate their eyes to the top of the tree, this space right here is the angle of elevation. Okay, so it's got to be made with a horizontal line. So like the opposite, like let's say, this is the top of a building, and there's somebody standing here and they are trying to look down at the ground. So the angle of depression, there has to still be a horizontal line of sight. And then if they are looking down, wherever they're looking here creates the angle of depression. So this would be the angle of depression, this would be the angle of elevation. All right, so the key here that is often missed is there's got to be this horizontal line of sight to create an angle with. So think of it as one side of the angle. Okay, so number one, actually let me go to the top. First of all, it says draw a picture, write a trig ratio, so we're using SOHCAHTOA, and then we're going to rewrite the equation so it's calculator ready. So you're basically going to solve it, and then round measures of segments to the nearest tenth, and measures of angles to the nearest degree. So we'll do whole numbers on angles, we'll do 1 decimal spot on segments. All right, we have a 20-foot ladder leans against a wall so that the base of the ladder is 8 feet from the base of the building. What is the ladder's angle of elevation? All right, so I'm just gonna make building. You can draw as nice of a picture as you want, but I'm gonna make a building. So the ladder is leaned against the wall. All right, so here's my ladder. So it's leaned against a wall so that the base of the ladder is 8 feet from the base of the building. So here's the base of the ladder. Here's the base of the building. This is going to be 8. So there's my triangle. The ladder itself is 20 feet. So since this is the ladder, the 20 goes along what now is the hypotenuse of this triangle. We are calculating the angle of elevation. So that's going to be right here. I'm going to call that X. Okay, so I am going to use SOHCAHTOA, but I'm going to have to do inverse sine, cosine, or tangent because I need an angle measure. So I have got the opposite, I'm going to label opposite, adjacent, hypotenuse. So because I'm working with adjacent and hypotenuse, I'm working with cosine. So you can think of this in one step or two. So I'm going to start here. I'm going to say that the cosine of x degrees is equal to adjacent 8 over 20. But in order to find the value of x, we're going to do the inverse cosine of this ratio. Okay, so like we did last section, so I'm going to use it in my calculator. I'm going to go like this. I'm going to enter it as 8 divided by 20, so I don't have to round it. I'm not necessarily going to use the fraction key. So inverse cosine of 8 divided by 20 is about 66.42. At the top it said nearest degree, so we'll just call that 66 degrees. Okay, so the angle of elevation is 66 degrees. So we need a picture, and then we are going to correctly find the angle of elevation or depression, or maybe it's given to us, and then find whatever we're looking to calculate. Okay, let's look at number 2. Number 2 says, let me get a different color here. A 50-meter vertical tower is braced with a cable secured at the top of the tower and tied 30 meters from the base. What is the angle of depression from the top of the tower to the point on the ground where the cable is tied? All right, I'm going to start with my 50-meter vertical tower, and I'm just going to represent that with a vertical line. Okay, so there's my 50-meter vertical tower. It's braced with a cable secured at the top, so I'm going to start here, and tied 30 meters from the base. So my cable is going to come through here diagonally, and it is secured 30 meters from the base. So the distance here is going to be 30. All right, so there's my right angle. What is the angle of depression from the top of the tower to the point on the ground where the cable is tied? Okay, so this is where it gets a little tricky. A lot of people have a tendency to call that the angle of depression. But the problem with that is, over here, we've got to have a horizontal line, and I don't have one there. So here's what we're going to do. I need to make a horizontal line. Okay, so I'm just going to make this horizontal line of sight. And so my angle of depression is going to be right there. Okay, so it's got to go from the horizontal down. Now, in order to find that value, there's a couple ways to do this. One way is to recognize that I just drew a line across the top parallel to the base. And so I then know that since my alternate interior angles are congruent, that means the angle at the top is the same as the angle down here in my triangle. Now, once I'm in my triangle, I can use my SOHCAHTOA acronym. I can use sine, cosine, or tangent. And whatever I get for x down here, it's going to match what I actually need. Okay. The other way to do it is to create, and I'm going to draw this and then erase it. The other way to do this is to say, all right, I'm going to close off this triangle, or I'm sorry, this square or rectangle, move my 50 over here and move my 30 up here, and then I have the same triangle that I'm going to work with. Okay, I'm going to take that off. You can certainly do that, but I tend to look at the alternate interior. So here you're going to do SOHCAHTOA. So we have our opposite. This is our adjacent. So then that is a tangent. So the tangent of x degrees is equal to opposite 50 over adjacent. So in order to actually find the degree measure, this is when we need the inverse tangent. Okay, so you're going to just type that into your calculator, round to the nearest tenth. So inverse tangent of 50 divided by 30 is 59.036, and I'm just rounding to the nearest whole number, so I get 59. All right, so those are two examples of angle of elevation and depression. I think I want to just maybe do one more with you, and then I would like you just to work through these on your own. I do have the answer key linked in Schoology. There will be quite a few angle of elevation and depression questions on the test. So this is definitely something I want you to complete. And if you have questions, please come back and let's work through those so that I can help you get the diagram set up. Because I think the key is getting the diagram set up, and then you're probably going to be fine. Okay, let's maybe do 3 and 4, and then I'll have you do the rest on your own. Okay. It says, at a point on the ground 50 feet from the foot of a tree, the angle of elevation to the top of the tree is 53 degrees. Find the height of the tree. Okay, at a point on the ground 50 feet from the foot of a tree. So down here, 50 feet this way, 50. The angle of elevation to the top of the tree. So from the horizontal up, so that angle of elevation I just drew was 53 degrees. Find the height of the tree. So I'm going to go ahead and just close off this right triangle. And we are ready to, I'm going to call that X, or you can call it H. So let's do SOHCAHTOA. All right, we've got from 53, I've got opposite, 50 is adjacent, and if it helps you to label H so you don't mix up the adjacent side. So O and A, I'm doing a tangent. All right, so I've got the tangent of 53 degrees equals opposite over adjacent, x over 50. Cross multiply and solve. So cross multiply, that would be x. And then I'm going to do the other way, 50 times tangent of 53 degrees. And looks like I just multiply. So 50 times tangent of 53. Now at the top it said round to the nearest tenth. So let's call that 66.4. And I do have a measure. We're in terms of feet. So always label, if you have a label, your final answer. All right, so that one is finding a side length. So we're not doing an inverse sine, cosine, tangent. We're doing a regular sine, cosine, and tangent. Okay, let's look at one more together. Number 4. From the top of a lighthouse, 210 feet high, the angle of depression of a boat is 27 degrees. Find the distance from the boat to the foot of the lighthouse. And the lighthouse was built at sea level. Okay, from the top of a lighthouse, the lighthouse is 210 feet high. So this is the lighthouse right here. I'm going to label that as my 210. And if you want to put a vertical line, you can. All right, the angle of depression of a boat is 27. All right, so I'm going to go like this. I'm going to draw this side of the triangle. But remember, the angle of depression is not right here because there's no horizontal. So I'm going to add over this kind of horizontal line of sight. So here is my angle of depression. So this is where my 27 degrees goes. Take that other dot off. Find the distance from the boat to the foot of the lighthouse. So I'm finding this distance right here. I'm going to put X. There's my 90-degree angle. Now let's get the angle of depression in the triangle itself. So these are parallel. So that means this is also a 27-degree angle by alternate interior angles. So now I have from 27, so here's hypotenuse, opposite, adjacent. O and A is tangent. So tangent of 27 degrees equals 210 over x, cross multiply. So I've got x times tangent of 27 equals 210 times 1 is 210. And then remember, tangent of 27 is simply a number. So divide by tangent of 27. Tangent of 27. Okay, and so these guys are going to divide out to be 1. So 210 divided by tangent of 27. So rounded to the nearest tenth, I've got 412 point, looks like 1. And going back up here to the top, feet is our unit. Okay, so there is our answer. Okay, so what I'd like you to do is keep going. I want you to draw a picture, add to the picture already there, and you're always drawing a triangle. Your goal is to make a right triangle so you can do SOHCAHTOA or inverse sine, cosine, tangent. And so these are just more word problems dealing with that. Okay, if you need anything, please send me a message.